For Lesson 1-6, we are looking at ordered pairs and relations. You have a couple of different vocabulary words, and notice for the notes, all you have are a couple of screenshots taken from your textbook. When this is the case on your note sheet, just make sure to read through the different problems for the lesson. Of course, you have your what you'll learn statements at the top and your vocabulary words on the left. All your vocabulary words are highlighted so you can copy down those definitions. But the screenshot that I took for your note sheet is right here, and so you need to make sure and fill in the boxes for the definitions or the labels. So these three boxes on your note sheet are empty. Please fill those in. And then there's also another screenshot a couple of pages ahead of that where you're filling in the domain and range. So make sure that you not only fill those in, but just glance through each of the example problems. Okay, read through it. If you need to watch a video tutor, that's fine. Make sure you access those tools to help you understand the content. For Lesson 1-6, we have a couple of different homework assignments. Make sure that you complete those assignments and let me know if you have any questions. This video will also cover Lesson 1-7, so continue to watch or pause the video and then resume when you're ready to do Lesson 1-7. For Lesson 1-7, we're talking about tables and equations. Let me get there on the online book here. For Lesson 1-7, we're going to be using multiple representations to represent relations. And we're also going to be translating among different verbal, tabular, graphical, and algebraic representations of relations. So quite a mouthful there, but we're talking about words and equations, and then using tables and graphs to display that information. You have a couple of vocabulary words, actually just one vocabulary word, equation, so make sure you get that definition down. And we're going to take a look at example 1, the got it section on your note sheet. So here's your note sheet. We're going to look at number 1 on page 37. So that says that Jenna picked the game card shown. Make a table for 4 different domain values. As you're doing your definitions, you'll remember, or hopefully you can look it back up again, that the domain values are the x values. And it also says to write down those domain values and write an algebraic expression for the rule, and then state the domain and range of the relation. So if you look back up here at example 1, it gives you a step-by-step procedure for doing that. We have an x value, or our domain. We have the rule, which we're going to write from this card right here. And then we have the y value, which is the range. So let's take a look at the rule. The rule says triple the number and then subtract 1. So no matter what number I choose, x, I'm going to triple it. So I'm going to put a 3 in front of it, meaning 3 times that number. And then I'm going to subtract 1 from it. So this is my equation. Okay, actually not my equation, it's my expression. Do you know the difference between an expression and equation? An expression does not have an equal sign, and an equation does. So this is an algebraic expression, 3x minus 1. And now we're going to pick 4 different domain values. Okay, I can pick the number 100 if I want to. It's not commonly chosen because we want to stick with numbers that are pretty small, but for this example, I'll go ahead and choose it. I can pick the number 0. 0 is always a really easy number to pick for the domain because anything times 0 is 0, and it's easy to work with. I'll pick the number 1, and then I'll pick the number 4. Okay, so those are my x values, also known as the domain. I'm going to make a table here similar to the example shown. I'd like you to do the same on your note sheet. Our rule is 3x minus 1. And so for each of those domain values, I'm going to plug that number in for x, and then I'm going to find the result, which is going to give me my y value or my range value. So 100 times 3 is 300. 300 minus 1 is 299. I skipped a step here, so I'm going to put that in my y value. And then in that middle column, I'm going to take 3 times 100, okay? And then I'm going to subtract 1. And if you want to put parentheses around there, that's going to make it show that it's multiplication. For 0, I'm going to take 3 times 0, and then I'm going to subtract 1. Well, 3 times 0 is 0. 0 minus 1 is negative 1. The next problem, or the next domain value, is 1. 3 times 1 is 3, and then 3 minus 1 is equal to 2. And finally, 3 times 4 is 12, and 12 minus 1 is 11. So let's check back the problem here. It says find 4 different domain values. I did that in this column. I wrote an algebraic expression in this column, and then I put the range values in this column. So now it's looking for step 3 where I list the domain and range values. And notice those aren't parentheses or brackets, they're like braces, squiggly parentheses is what you can think of them as, but braces look like this, and the domain values that we chose are 0, 1, 4, and 100. Now you might be thinking, why didn't you write those in the order that you put them in the table? Well, it's just something you do is you write them in order from least to greatest. Okay, so the domain is equal to 0, 1, 4, and 100. And then the range values are these guys right here in this column. And again, I'm just going to put those in as lining up here. 0 would be negative 1, 1 would be 2, and then 4 would be 11, and 100 would be 299. And notice that those work out to be in order from least to greatest. So for example 1, you list the domain and range in addition to the table. That's a lot of information, but I gave you a big box on your note sheet to fill all of that in. Next, we'll go to 2A and B on page 38 to work through. On 38, it says that sound travels at about 1,088 feet per second at 32 degrees Fahrenheit in dry air at sea level. It says write an equation. So in the last example, we wrote an expression, but in this one, we're going to write an equation, which is going to be something that has an equal sign in it. Okay, and what we're going to do is we're going to take 1,088 and we're going to multiply that by the number of seconds. Okay, and in part B it tells us the seconds, but we want a general equation to use. And so what we're going to do is we're going to represent that with a variable. You could put S for seconds, you could put X. It really doesn't matter what variable you use. And we're going to set that equal to another number, which at this point we don't know. We're just setting up a general equation. It's going to be y equals 1088x. Okay, so there's our equation. Now B says to make a table to find the distance that it travels at 0, 1, 2, and 3 seconds, and then graph the ordered pairs. Okay, so the table would look very much like this one shown in the example, where we have x, the values at 0, 1, 2, and 3 seconds. And then we're going to plug that in for our x value here, and then multiply it by the 1,088. So 1,088 times 0 is 0, times 1 is 1, doubled is 2,176, 2,176. Let's go ahead and fill in these other values here, 0, and then 1,088. And then we're going to add those together to get what's times 3. You could also use a calculator to check, but let's go ahead and add that up. All right, so we've made a table to find the distance. You might notice that this table looks a little bit different than the table shown. This is what's referred to as a T table. It's like a lowercase t, and it's showing the data a little bit differently than what we're shown here. I'm missing a column where we actually substitute that number in. It's not right or wrong, it's just another way of showing your work. But we did make the table and we found the values at those different seconds. I'm not going to graph the ordered pair just for the sake of time, but when you have to make a graph of something, you can do a makeshift graph pretty quickly. And when we're talking with numbers in the thousands, we're not going to obviously count by ones, but we could put the 0.00, and then we could put 1 and then 1088 here. We could do some estimating. But basically what we're saying here is as the number of seconds increases, what happens to the error? Okay, does it increase? Does it decrease? That's something that we can have you think about as you're processing these problems. Okay, and if you have any questions about any of these examples that I worked out or any of the problems on your worksheet, just let me know and we can work through them together.